Okay, so let's start. So one question students asked.
这个是 review 了是吧？
Yeah, review. Yes. Asked is that what if a student did not register for any courses until the end of the add-drop period? What happens? So it's not in the requirements. It's not specified as to the your how to handle it. It just says you must register for at least one course. So it's up to you to handle the situation. You can send a reminder email, or you can just don't allow them to register, or do some give some error message. It's up to you how to handle it. So the requirements is a high-level requirement. So there's a lot of details, error situations, alternative flows that you have to handle yourself. So let's start the review. It's a very a high-level overview of the entire course. So we'll start from the first chapter on quality characteristics, quality design, design goals. You may have many design goals. It's impossible to achieve all of them. Therefore, you should prioritize the design goals for your project. If your project is a safety critical system, then you should aim for reliability as the primary goal. But if it's not, then you should perhaps the time to market is more important. So choose the most important qualities and base the development around these. Reduce the complexity of designing the system. So modular development is very important for large software systems. So divide and conquer. You develop a large system into modules, and a module is any piece of a system that makes sense to consider separately. But modules have interactions. So interface abstracts a module, so the developer does not have to know how the module is implemented, so that you can reduce the complexity of understanding the system. So instead of other modules can call into this module within the module's code anywhere, you impose the interface so the other modules can only see the interface. So the interface encapsulates a module, so the developer cannot use knowledge about how the module is implemented. So you can change the module without affecting the rest of the system. Reduce complexity of maintaining the system. There's abstraction. Yeah, abstracts a module so the developer does not have to know how the module is implemented. We'll make a distinction here. By abstraction, it means that for another module, you do not need to know the implementation details to use it. But for encapsulation, you cannot use the knowledge about the implementation details. One is do not need, one is cannot. So encapsulation helps you to maintain the system. Abstraction helps you to understand the system. So modular development, we see module-based, it's the same thing as component-based in this course. Modules and components are synonyms. So it reduces the complexity of cost and time estimates for developing a system. We discussed project management, estimating a project cost in terms of human and monetary and time is very difficult. So it's always easier to do the estimation for a small piece than for a large piece. Therefore, modular development helps you to estimate the cost for each module and then sum up the costs and time for larger systems. So the software engineering challenges are to design good modules with the right interfaces and specific architectures to support modules. Architecture is a high-level skeleton where modules are the muscles. You plug in the modules into the architecture. So the first chapter essentially says, have the appropriate design goals. Pick and choose the quality design goals you want for your project. Don't try to aim for all design goals. It's not possible. Modular development and software engineering techniques, including software methodology, processes. So programming in the large, modeling and documentation are very important, not just coding. So they may seem tedious and boring, but they're essential for helping to reduce complexity and building better software systems. So next chapter we discussed UML, Unified Modeling Language. It's an industry standard object-oriented modeling language, but can also be used for non-OO systems. That is, some diagrams are OO specific, like class diagrams are OO, very OO, but others are not that OO, like the sequence diagrams. It can be used for any system. So basic premise is that software systems can be modeled as collections of collaborating objects. So here's an object. We discuss objects first and then in class next. So it's a instance classifier distinction. Object is this thing with boundaries, and it can respond to a request for an operation. Request means that in a real software system, it's a method invocation. In all language, we often say it's a message arriving from outside. The message can be a real network message or could be just a method invocation. So here's an object with 3 operations. Balance, this really should be get balance. So it's an operation. Deposit and withdraw, both with an argument, but balance doesn't have an argument, but has a return value. Interface describes the operations which an object can perform. Notice that interface does not include attributes. It's only a collection of operations. Now, in C++, you may have public attributes. If you say public double balance, that's bad design practice. So here we say interface should only consist of operations. If you have a public attribute, you should turn it into a private attribute and put a operation get attribute as a public interface. So object has identity. This is the object identifier that uniquely identifies this object from every other object in the universe. So typically, it's stored internally within the object's representation in the computer. We don't need to see it. We don't model it. That's why it's drawn outside. And then it has state. State are the values of the attributes: account number and balance. And interface. We call it behavior. That is, this describes how the object reacts to the
What's the difference between behavior and user interface?
Object interface. So behavior is really how the object reacts. You remember the state machines we discussed? That describes behavior. That is, when it gets a message, it performs a bunch of operations, makes a transition, sends another message out. So operations interface is the is what the object can do, but it's a list of operations. But the behavior is the actual how you invoke these operations at runtime. It can be a state machine, or but for simpler objects, you don't have to have a state machine. So, yeah, feel free to interrupt me with any unclear points. Otherwise, I go pretty fast. So, information hiding. Here we see an object with interfaces, where the user calls the interface, gets a response back, and an object can call another object's interface, request something, and get a response back. The user could be referring to the human user interacting with the system via a user interface, like a button. So here, we saw interface before, right, for modules. Here, objects are really modules in the OO system. So it's really a special case of the module concept we discussed in the introduction. Except modules can be very generic. A module can be an object, can be a subsystem with hundreds of objects. So objects interface encapsulates and abstracts an object with information hiding, same as modules, because it's a special module, essentially. Interface is public, collection of operations. Implementation is private. That is the method behind each operation. Information hiding helps promote modular development. So class is a classifier. It describes a group of objects that have common state, behavior, relationships, semantics. Semantics is the meaning. So we didn't discuss semantics much in this course. But there's a whole area of study on formal semantics for programming languages. So they have common state behavior relationship. It means that they have common attributes, common operations. If there's a state machine, they have common state machine. So a class is a template for creating objects, like a stamp. You stamp out objects. All the objects look alike. They share common attributes, but their attribute values are different. So a class design should capture one and only one abstraction. So it should have one major theme. It shouldn't have two general class that does everything. Name choosing the vocabulary of the problem domain. That is, try to make it understandable to the client. Meaningful and traceable. So an attribute is has a name, type, visibility, initial value, which is optional, multiplicity. That is the number of simultaneous values. A person may have two or more telephone numbers. So if a telephone number is an attribute, you can have 2 or 3 as the multiplicity, or you can have 2 or 3 separate attributes. Each one has multiplicity 1. It's a design decision. So the type here doesn't have to be programming language types. You can say salary, name, sex, color. They can be types used in especially in the requirement stage. Later in the design stage, then you need to use computer science computer types like double and int to describe types. But in the early stage, you can use any intuitive type you find convenient. So visibility is public, private, protected, and packaged. So protected attribute can be seen by the class and all its subclasses in the inheritance hierarchy. A package visibility means that it can be seen in for classes in the same package, which we discuss package later. Changeability, whether it's no constraint, that is you can change it any way you like. Frozen, it cannot be changed, or add only. This is when you can add a new telephone number, for example, but you cannot delete any telephone numbers. So a base attribute versus derived attribute. So birth date could be a base attribute. Age is derived. You can just do a subtraction to get the age from the birth date. So operation is a functional transformation that may be applied to or by objects in a class. So say company pay dividends. That's the operation done by a company to the shareholders. And course register, that's the operation done to the course by a student, right? So it could be applied to or by objects. So operation has signature, visibility, and the side effects. So for the bank account example, balance is an operation with no side effects, because it doesn't change the state of an object. But deposit and withdraw have side effects. They change the state, that is the balance value. So method is an implementation of an operation. So it's a classifier instance distinction. One operation may have multiple methods behind it. So a polymorphic operation, that's an operation with several different methods. Say account has an operation pay interest. Then you may have in the savings account, you may have an operation with the same name, pay interest, but with a different method implementation from that in the checkings account. They have different formulas at different interest rates, right? So this is really polymorphic operations are used when you have inheritance. So this is really discussed later in generalization and inheritance. Dynamic binding refers to when you choose the method to execute for an operation based on the object's class. So if you learn C++, you should know that dynamic binding, that is when you have a pointer with type account, then we will invoke the operation on this pointer. The actual method invoked is dependent on the actual type of the object, not the compile time static type. It's a dynamic type. So here's the basic notation: class name, attribute, and operation. This extra compartment is not really used in this course. So essentially, it's 3 compartments. Not every class looks like this. We saw many other classes that look very different. An actor is a class, right? Actor is something that looks like this. So, we saw, say, entity class, right? Or control class. So all these are just classes. They just use special icons to make it more clear to the reader. You can always draw it as a 3-compartment shape with a stereotype, with square brackets, with a stereotype in it. You can say it's a actor, it's a entity class, etc. as annotation above the class name. So the bank account has name, bank account, attributes, and operations. Private, public. The type could be money, right? It's not a valid computer type, but it's okay in the requirement stage. So, and also you have a class scope, attributes and operations with an underline, right? Underline means that the count is the total number of bank account objects in the system. Therefore, it's not the attribute of a specific object. It's a class attribute. Similarly, create and increment count are used when creating a new object and incrementing the total number of objects in the system. Therefore, these are class operations. Notice that increment count is a private operation. It means that it shouldn't be called by other objects directly. It should be only called within the create method. Right? You cannot increment the object count without doing a create. So that's why you make it private. But get count is okay. It's a public operation, because it has no side effects. Just get a count of the total number of objects. So all the others are object attributes and operations. They apply to a single object. Class attribute and operations. So generalization, specialization. So we generally use the word generalization to refer to this this kind of relationship, but you should really read it as, if you go from down to up, it's called generalization. But if you go from top to down, it's called specialization. It's in two different directions. So here you have a superclass, also called a base class, and subclass, also called child class. So everything in the superclass, all the attributes and operations are inherited by the subclass. So checking has 3 attributes and 3 operations, even though it only shows 1 within its own compartment. It inherits everything from the bank account. But it can add new things. It cannot subtract things from the superclass. So if you find that you need to subtract some attributes and operations, then it's not a proper inheritance relationship. You shouldn't draw it as inheritance. Also, you can redefine the operations with a different method. However, you cannot change the signature. So you cannot add arguments or remove arguments and change the return type, etc. That's not allowed. You can only change that because it's part of the operation. You can only change the method behind the operation. So add new attributes operations. These are two new attributes and one new operation. Override methods. Notice override methods. Operation signature cannot be changed. So that's single inheritance. Now, you can have multiple inheritance. So suppose you have a hybrid account with characteristics of both checking and savings. You can write checks from it, and you can get interest from it. Then you can do this multiple inheritance. But you may run into difficulties. So the withdrawal operation is inherited from checking to checking savings. And also from this path, you you may get this same operation from both branches. Now, for this case, it's perhaps okay because withdrawal is not overridden in checking or savings. But what if checking overrides withdrawal with one method and savings overrides it with another method? Which method should the checking savings hybrid account have? Now, that is a difficulty. That's why multiple inheritance is not recommended for most systems. You can say it's a user-defined order. That is, the user says, okay, it should inherit the one from checking. Or predefined order. So, for example, always prefer all the methods in the checking to that of the savings. Or redefine names. You can say checking withdrawal and saving withdrawal. Redefine the names so you can have different operations. So, redefine name is only for attributes. So you have new attributes. Abstract class is shown with this italic font. It means that it's a container for definitions, but you cannot instantiate these objects from this class. For example, you can have account as the superclass with a bunch of attributes and operations in it. But it doesn't make sense to have any account objects. That's not a checking or savings account. Therefore, you make it abstract so that you cannot instantiate any instances. So this is done in, you have keyword abstract in C++. So operations may also be abstract, so which have no method specified. It's empty. Signature only. So this could be indicated in C++ by adding equals 0 at the end of the operation signature. So in UML, you also use italics for abstract classes and operations. Coverage. So a player, tennis and soccer player are both players, but they're overlapping because a person can play both. Disjoint is when account can be a personal or business, but never both. Complete, a student, university student, can be undergrad or postgrad, but there's no other type of student. Incomplete is when the superclass object is not a member of any subclass. Some superclass object, say tree, you have many different types of trees, Therefore, oak, elm, and birch are obviously incomplete. So stereotype is an annotation to dynamically extend classes to denote that some class is a special class. The notation is this: with the square brackets, with these brackets, angular brackets, and the keyword inside. Here, these are the control, boundary, and entity classes used in the analysis document. You can define your own stereotypes. These are predefined, commonly accepted stereotypes for control, entity, and boundary. Or you can use icons to represent a stereotyped class. Instead of this guy, you can use this guy to make it more clear. Notice that you can omit the attribute and operation compartments from the class notation to have only a single compartment with a name. If the situation doesn't require you, it's not necessary to specify the attributes and operations. So link is a physical or conceptual relationship between object instances. So person, organization, and course. So Fred works for an organization, teaches a course, and so on. So a link allows an object to send a message to another object, which may be a method operation invocation. Without a link, you cannot communicate between the objects. You can communicate indirectly if there's an indirect path to the object, but messages can only travel along links. Association is the classifier at the class level. So a person teaches course, so that's a association, and person works for organization, that's an association. So in the class diagram, you draw the association as lines between classes. So they are inherently bidirectional. That is, you can navigate to in either direction. But optionally, if you draw an arrow, it means that you can only navigate in one direction. If you don't draw arrows, it means it's bidirectional. So it means that the source object has a reference to the target object at the object level. Reference meaning a pointer or a reference in the Java. So can show readability of associations using triangle. So this little arrow here is really to help you read. Say this triangle here means that person teaches course, not a course teaches person. So you can omit it if it's obvious. So there can be several associations between two classes, and each association may get turned into one link between two objects, or even with the same class. So a person married to another person, but it doesn't mean that the person is married to himself. It means that two objects have the same type, person, who are married. So notice that there's a question in the midterm that asks you, I forgot the exact wording. Essentially, it says you can have multiple associations between two classes and multiple links between two objects, but for every association, there's only one link for that association. Say here, a person attended university. It's an association. And then between objects, you can only have one link between James Kwok and HKUST objects that correspond to the attended association. But you cannot have two links for the same association. You can have unary, binary, and ternary associations. Ternary associations are rare. Often they can be represented as two binary associations. N-ary are even more rare. Vast majority are binary associations. Multiplicity restricts number of objects in a class. So instructor can teach 0 or more courses. So 0 ... means that there's no upper bound. In your course project, you have 2 as the upper bound. For a given course, you may have 1 or more instructors. So 1 ... So star means unlimited. So if it's 1 ... 1, you can use abbreviation of 1. 0 ... can be abbreviated as a single star. So country and city with the capital of association. So a country must have one and only one capital. So 1 ... 1, which is just 1, and a city, a city may be the capital of 0 or 1 countries. So every employee must be assigned to a single department, and a department can have 0 or more employees. So say sales has 2 employees, production has 0 employees, marketing has 3. So and finally, many-to-many associations, where a supplier can supply 0 or more parts. A part can be supplied by 0 or more suppliers. So for ternary association, multiplicity is more involved. So here the multiplicity says 0, 1 professors for any pair of course student, and many courses for any pair of student professor. So role names are optional. A person plays the role of employee, and company plays the role of employer. So you can navigate the association, especially in OCR. When you write OCR statement, you can navigate the association by the role name or by the class name. Say you can say person dot company to navigate from person to company, or you can say person.employer to navigate from person to company. So both are okay. So here, when you have unary associations, role names are necessary to distinguish who is the boss, who is the worker. So this is the case for your course project, a course prerequisite. You have a course with a prerequisite self-association, and one end is the course, another end is the prerequisite. Now, association class is needed in this situation where you need to associate an attribute with the association. Say the grade of the enrolling association between every student course pair. So notice that only if you need to specify extra attributes, then you need an association class. Otherwise, you don't need it. So another way is to write the semester as a separate class instead of an association class. And use two associations. Students take in a semester a course offered. A course is offered in a semester, as opposed to a single association with an association class. Both are okay, but the association class, this approach is more specific, while this separate class approach is more generic. Therefore, when possible, you should try to use the this association class like this to avoid any ambiguities when you use a separate class. So in this case, both are okay, but the association class approach is more clear. So for this example, a person works for a company, draws the salary. So where do you put the salary? Obviously, obvious solution is to have an association class here, works for, with the salary attribute, right? But it's not really necessary if the person only works for one company. You can put the salary attribute in the person class, right? So it's only needed for many-to-many associations like student course, and you have a grade for every student course pair. A student takes many courses, and course has many students. But here, if it's one-to-many associations, say star one association, then you really can put it in a person class. But if the person holds many jobs, 2 or more jobs, then you need to place it in an association class. Well, it's not wrong to have a separate association class, but it's not necessary. So aggregation composition. Aggregation is this open shape. Composition is this closed dark shape. If its main card is 0, mask card is 1 or star, then it's aggregation. It means that a computer can have 0 or more disks. A course can have 1 or more course offerings. So association, composition, and aggregation are special types of associations. Therefore, you can always use association whenever aggregation or composition is used. but you can not always replace association with aggregation or composition. So again, it's a question of one is more general, one is more specific. So not all has associations or aggregations. Say I have I have a arm, right? That's perhaps aggregation, but I have a student. Perhaps that's not an aggregation or composition. It's more of an association. So it's a judgment decision. So relationships are generalization we discussed, association, and dependency and realization are not really discussed in this course. So Carlon example, so we can pull out a common attribute name into the superclass owner. So owner can be a person owner or a company owner. So constraints are the assertion about properties. So say here balance greater than this much and balance, so you can place it as this is a notation of a note in UML. It's like a box with a little folded corner. It's a very informal, you can put anything in it. So the point of OCR is to make it more formalized so that it's machine checkable. Perhaps you can provide it into a formal verification tool that can read it and verify it. So a note is only for human readers. So OCR has context and invariant. So context is the where do you start from? Say account ACC is the object name, colon preferred savings is the class name, and invariant says account minimum colon. This is the invariant. This is the constraint name, and this is the actual constraint. This says ACC, which is the object name referred in the context, dot balance. Balance is the attribute within the account object greater than or equal to 100,000. So this is the more formal way of stating the same requirement as the informal note in the previous slide. So here we see navigation expressions. So here we see a context post invariant colon salary greater than 1,000. Essentially, this is saying that you're starting from a post object. Notice that post is the class name. Yes, context name is optional. So you can also say context name P colon post and P dot salary, like in the previous account example. So here it's omitted, right? Here you can say just class name and then invariant salary because it's very simple. There's no other classes. So you can omit the class object name from the context and invariant specification. And directly related classes by navigating a single association, indirectly related classes by navigating more associations. So here you're saying department dot division. So here you're navigating from the person to department and then to division. So you're starting from the context always, right? So person to department and then to division, right? Navigation. So you can, this object name is omitted, so you can say P colon person, and then P dot department division and P dot employer. So it means that you're navigating from this path to department to division, and then from here to here, from person to division. Then here you use the role name for navigation instead of class name. You can also say person.division. That's okay too, because you have a role name. It's more clear to use the role name for navigation. And then these two must be the same. So from this path and from the top path, it must land on the same division object. That's what the OCR is saying. So employer is directly related class, is the division, and the other division is indirectly related via the department. So I think I'll skip these unless you have questions. So the key is to remember always to navigate from the context to other classes by navigating the associations. If there's no association between two classes, you cannot navigate. Or the direction, if from class A to class B, then you cannot go from class B to class A for navigation. The pre and post conditions for operation constraints. We'll discuss pre and post conditions for the use case flow of events. But here, you can also use it for operation. So for withdrawal operation, precondition is amount less than balance. Only when this precondition is satisfied can you invoke the operation. And post condition is balance equals balance at pre minus amount. This is a keyword indicating that the balance before invocation of the operation. So mortgage example, pretty simple. Person has a mortgage is not empty, implies house not empty. So another way of saying it is a borrower.house. So borrower is the role name of the person to mortgage association. So summary, you have the class diagram notation with the three compartments. You have different classifier instance pairs. A class object is obvious pair, attribute and value, operation method, and association link. One is the instance level, object level. One is the class level, classifier. So you have this generalization with different constraints and association with different multiplicities, and composition, aggregation, plus OCR for constraints. Okay, so that's class diagrams. So now we move to processes, software development process. 4 P's. Obviously, the product is the final goal. set of models, code, manuals delivered to the client. To reach that goal, you need a project, and you need a process, and obviously people participate in the project. So the process is a set of activities, workflows, like a recipe for how to carry out the different activities. It's a template because it's not a recipe exactly. It's a template that you need to customize for your particular project. Needs to be adapted for different situations. So the most primitive one is code and fix, where you get the requirements, you just start coding, and you fix bugs along the way. So that's a counterexample for the real process. So more structured process is needed. Waterfall is this very rigorous formal process where you go from requirements to analysis to coding to testing to maintenance. And every step you produce a document. After requirements, you produce a requirements document. After analysis and design, you produce a design document. In our project, we actually have separate analysis stage with a separate analysis document, and coding and testing. So it's called waterfall because you always go forward and never go back. That is, at every step, you may loop back to the within the same step to do some iterations, but you never go back, say, from analysis design back to requirements. So once your requirements are done, they're done. You cannot change it. And then in the maintenance stage, you can modify either one and then follow the waterfall process. Say you modify analysis, you fall from analysis down to coding to testing again. So this is applicable only when requirements are well understood and not likely to change. Because it's a waterfall, you cannot fall upwards. So you cannot modify the requirements. That's very rigid. So prototyping is when you do a quick design, build a prototype, client evaluation the prototype, refine it, and then go through the iterations and refine the prototype. So it has more discipline than the code and fix process. It's useful when requirements are vague or unknown. So it allows exploration of user interface and functionality, so you can show the client a prototype early, user interface prototype early. So what to do with the prototype? Ideally, you should throw it away and start from scratch. But many times you evolve it into the final product. So phased is when you build many releases. So you build it, release 1, give it to the users and use it as a beta tester. Release 2 and use it, and release 3. So phased has two types. One is incremental, where you build a partial system. Okay, what happens? So something's broken. So you build a partial system, and then you gradually put them together. Iterative development is when you build the full system, but perhaps it's very rough. And then you gradually add details. So many organizations use a combination of both. So Agile is the phased approach where the major goal is responsive to change with the client involvement. So in typical say waterfall process, clients are involved in the requirement stage, and then they are not involved until the delivery. But in Agile, client is involved at every step. So extreme programming is one type of Agile process. So you do some rough requirements and analysis, and then you do implementation. Use test-driven development. That is, you design test cases as you're developing modules. They're developed in pair. Instead of doing the development first and design test cases in the testing stage, like in the waterfall process, here you're designing the tests concurrently with the modules. And you're using pair programming. That is, you have a developer and tester paired together. So major emphasis is in implementation. So requirements are very rough. Oftentimes you don't have a formal requirements document. So only for small-scale projects where the client's requirements are vague. So Spiral, you do planning and risk analysis and engineering and client evaluation and go around the Spiral many times. So the distinguishing characteristic of Spiral is risk analysis, which is absent in all the other processes. Risks is anything that can go wrong, including technical risks and non-technical risks, like the people management approval. Dealing with risks, you can avoid it by changing requirements. Perhaps the system is too ambitious. You make it smaller, confine its scope, mitigate, control it, and monitor for risks. So project killer risks, prioritize and deal with biggest risks as early as possible. So unified process is really a combination of many characteristics of the other processes. So you have 4 phases: inception, elaboration, construction, and transition. And then each of the steps, from requirements down to testing, is part of the engineering workflow. And you have 2 management workflows, software QA and management, project management. So we discussed this course essentially following this direction from top to down. So in the actual life cycle, you're doing all the workflows from requirements down to testing and then to project management many times. So this is very different from waterfall. In waterfall, you cannot go back to requirements. But here, you're revisiting the requirements constantly. So each of these vertical workflow is called iteration. So and from iteration to iteration, you have increments. So, and at the end of each phase, you have a major milestone with the heavy bar. So it selects from the best practices of previous processes and defines a set of workflows, activities, and artifacts, models. Artifacts can be the actual source code, or it can be the more abstract documents, like requirements documents and design documents. So it's a use case driven. That is, you should have the traceability from each use case to later analysis and design specification. So, for example, in your activity 3 and 4, when you turn in your design documents, you should be able to trace back from a design model back to the use case, which use case it is for. And risk-driven, so this is borrowed from the spiral process. So you do risk analysis. Software architecture-centric. That is, you build a skeleton architecture, and then you add on the muscles. Iterative and incremental. So it's use case driven. So use case model we discussed in requirements stage. So actor is the user or human or other systems like billing system or time. Use case is a piece of functionality. And use case model is the complete functionality, including all the actors and use cases. Used to reach agreement with the client on the system's required functionality as a contract. Helps project managers plan, assign, monitor tasks. So drive the development process. You transform the use case model into analysis, design, and implementation models. That is, base your analysis and design models on the use case, including the flow of events. Support traceability between models. So 4+1 view shows it clearly. Use case view sits in the middle. So everything must be related to a use case. Then you have logical view, where analysis and design models are part of the logical view. Implementation view is the implementation and test models. So deployment view is for the IT staff. So how do you download and install the software? Process view is the for non-functional requirements like performance, scalability, and throughput. So here the process is the operating system process, not the software development process. It's like a system has a process for managing files and another process for something else. So the things you see in the process manager. So it's primarily a model building activity. So that's the 4+1 view. Iteration. One iteration is one step through the workflows from top to down. Increment is from iteration to iteration, from left to right. Each iteration results in a working product. Each increment establishes a baseline. And notice that we discussed the baseline in the software configuration management. To be a baseline, you must pass a rigorous review process. Control the iterations and the increments. So this is change control done by software configuration management. So developing a system in small steps allows us to mitigate risks, get feedback early. By having an early prototype, you can show it to the clients. So what to select to put in the iteration? So you target the highest risk use cases, and use cases that extend product functionality So prioritize the use cases when you are trying to plan the iterations. Each iteration is assessed at its conclusion to determine to do assessment as the missed new requirements and how do the remaining risks affect the project. And if the risks are too great, you make a go no-go decision, like in the spiral process. Regression testing. At the end of each iteration, we discuss regression testing is to test the old functionality to make sure that your new updates do not break your any old functionality. So planning is iterative, just like development. So we discussed the planning in the project management software development plan. So it's not realistic to do a plan at the beginning and stick to the plan. You need to modify the plan along the way. It's iterative planning based on new information. Planning is intimately tied to estimation, right? Only when you can estimate how long it takes can you plan for it. And estimation is notoriously difficult. So the sequence of iterations that always move the project forward, never having to go back. It means that it always moves from left to right. Never from right to left, but you can move from bottom to top. That is, you can go back to requirements to design at every iteration. That's okay, but you don't go to the left. Okay, so we finished these two. We'll discuss continue next class. So I think I'll be faster next class.